Hi everyone, welcome back. Today we are going to show you a project called Knee Osteoarthritis disease detection using deep learning on X-ray images. First, we'll see some sample results. So now you see this is a mild case of arthritis where we upload image and we are getting the result. It is mild, and what are the things you are getting? Mild joint space narrowing, possible small bone spurs, and early sign of cartilage wear. What will be the feature problem? That also is being detected. What is the main cause? That also is being detected on. What is possible treatment? The treatment includes physical therapy, pain management, weight control, and possible use of joint supplements. So in the same manner, we can try a few more scan images, CT scan images. We will try with severe. So here our model is able to detect it as a severe. So to make you understand this is a severe image, even I'm printing here and here, okay, both the location. And this is severe case of knee osteoarthritis where what is the main cause? A severe loss of joint space, large bone deformities, major cartilage loss, and advanced osteoarthritis features. What is possible treatment in this case? Surgical intervention after recommended, if recommended. Example, total knee replacement, otherwise along with the strong pain management and physical rehabilitation, so that can cure this problem. So now you saw the results, but I will be showing you entire web application, how we built, how we integrated the models, how we trained the models, what are the models we used, what accuracy we are getting, why our proposed methodology is far better than the existing methodologies by going through multiple IEEE papers. So now we'll try to discuss what is this disease is first of all, and what is the causes and all those things. Then we'll try to discuss some IEEE papers for your existing system as well as for proposed system. We will propose our own methodology better than those IEEE papers, and our model should be better than the existing system. So all those things we'll discuss one by one, and then finally I will try to discuss how we built this code, what are the models we use, what accuracies we are getting, what different pre-processing techniques are being used in our project. All those things will be done. And if you are new to our channel, we provide like this technical projects like in AI, ML, IoT, embedded system, in all other domains. So you can go to our channel, home channel, and you can see there are so many n number of videos on this. And the main thing is, if you want the complete code and the complete support, you can always contact us. Our team will be responding with you, and we'll provide you the complete project with the documentation, with paper research, and as well as we'll be even making the changes in these existing systems according to your own customizations. If you are having your own idea, if you are having your own data sets, you can come up with anything like that. So we even try to implement according to your interest, and we will help you. So now we'll discuss about this project. So for this project we gone through three different papers. All of them are IEEE papers. Okay, so we open them here. You can see the first paper is Knee Osteoarthritis analysis using deep learning and explainable AI on X-ray images. So this is the first paper. The next paper is that knee osteoarthritis detection using deep feature-based convolution neural network. And the third paper is knee osteoarthritis prediction using deep learning. So all these three papers, we will go through them one by one. We will understand their existing system. This is needed for any research before moving further. So if you don't know what is already existing, how you will define the new thing? So you need to understand the existing system of the present papers. Then we'll discuss what we are doing extra and how we are getting some good results. All those things one by one will be discussed now. So we'll take this paper and we'll go to their methodology, and we'll try to understand what dataset they are using, what type of classes are there in that dataset. Is it multi-class? Is it binary? What is that? We'll understand. Now we made a small documentation for this. You can see here, this is complete detail about that particular paper. You can see here, knee osteoarthritis analysis using deep learning and explainable AI on X-ray images. We are also using explainable AI in our case. So we are doing what this paper is already saying, explainable AI, but we are doing something extra. What is that extra we are doing? We'll discuss those things. First, in this paper, in the existing paper, the data set they used is knee osteoarthritis severity grading data set, University of Florida. It is from University of Florida, and total images they are using is 8,260 X-ray images. They are splitting 70 for training, 10 for validation, 20 for testing, 20% for testing. Models that are being used in this paper are VGG16, VGG19, ResNet 50 and ResNet 101 with EfficientNet B7. And for fine tuning, what they are doing in fine tuning part. So they are using VGG, ResNet and EfficientNet as a pre-trained base models. They are using some extra layers from their side. We need to use our own extra layers for the existing models. They are working only with 2 classes. For multiple classes they are going with 0 to 4, that is 5 different grades. For binary there are only 2 classes, class 0 and class 1, that is doubtful and mild. And for 5 classes it will be doubtful, mild, moderate and severe. In our case we are almost using the same data set. And for explainability, for explainable AI they are using GradCam. What is this GradCam? I will show you how it looks. So in our case how it is looking like, yeah, you can see in our case it will try to tell us clearly which part of the image is the most important part for saying this is actually knee arthritis. So if I want to say this particular X-ray scan says the particular condition is knee osteoarthritis is mild, then my model says in explainable AI this particular gap is the most important area, so you need to concentrate on this part. So it also predicting based on this gap, and their configuration setups they are using here. And yeah, the problem with this paper is so they are not providing us exact numbers. What is exact accuracy? Those things are not much clear. For example, if I go through this, their result we need. Okay, so finally we come up with the parameters like this. So they are using it as an image here, you can see. So their accuracy, the maximum accuracy they are getting is around subset 2, subset 1 are like that, 77, 75, 98 and 99.88 for EfficientNet and another models. They are using different subsets. They are not using entire thing at once. And this is only for binary. Remember, the top 4 subsets are binary. It means binary means 2 classes, not multi-class. When you increase the class number, you see their accuracy dropped like anything. Their accuracy is 0.56, 56%, which is really nothing, which is very worst. In our case, what we are getting? We are getting 97% training accuracy with more than 92% validation accuracy. If you don't believe me, I can show you the result also. Can you see this? 93.80, more than 92, 93.80 in our case. Okay, so we are also using all the 5 classes which that paper is using. So why this sudden reduction in their case? Why we are getting far more better result than this paper? What extra we are doing? All those things I will discuss one by one. It means I just wanted to show you that this paper is at most in the result at the end they are getting at most around for multi-class I am telling you they are getting around 90. This is not, this is like only two classes. We need to check multi-class is only two class they are discussing. Multi-class is very worst. Here it is 56, 67. These are all only binary class, only two class they are getting very good result, but two class is very small. Okay, only two classes they are taking, but we should work on five classes, so that's why they are getting some good number 99 वगैरह. But when they are mentioning here multi-class 67.16, which is far worst result. Okay, they can proceed, they could have got little bit more better result. I think in our case we are getting around 93% testing accuracy, as well as training is more than 97%. So this is about paper 1. So paper 1 it is going very bad. Now we'll understand paper 2 what they are doing. Why it is happening in these paper cases? They are not handling the data properly. They are not concentrating on pre-processing. They are not concentrating on balancing. They are not doing any region of interest highlighting. They are not doing anything here. They are directly feeding that data, because if they had done anything like that, they could have mentioned all those things here. There is nothing mentioned. Only they are mentioning like we are using explainable AI or like that. Explainable AI doesn't increase the model's capability. It increases model's analysis. The way we analyze will be better using explainable AI. And the second paper is Knee Osteoarthritis detection using deep feature based on convolution neural network. So in this IEEE paper, this paper is again using only 3 classes, and this paper we will see now here. We already made a note of that. You can see here. This is the detail of that second paper. So here they are using a data set called Protect PRS 500. Okay, so 500E X-ray machine images they are getting, and image types are 8-bit grayscale knee X-ray images with image size 1352455. They are using their own data, and healthy 203 images, unhealthy 200 images, total 403. This is binary images, binary class. What we say, it means only two class, yes or no, like that condition. So they are splitting the dataset under the pre-processing. This paper is doing little bit to make sure it works better. So they are using high pass filters like Gaussian window FIR filters and Fourier transforms, and this is done with help of not with help of Python. They done with help of MATLAB. So they are trying to do region of interest detection, and Gaussian smoothing filters they are using, and then they are trying to remove the BG, but the BG will already be white. Deep feature extraction, CNN they are using for feature extractions, and machine learning and CNN combination. This paper is working with deep learning plus machine learning in combination. With deep learning they are extracting the features, with machine learning they are doing the predictive models, and their accuracy for these 3 classes, only 3 classes, remember, they are not going with multi-class, only 2 class they are going with, they are not going with multi-class. Like at most that's KNN giving them 90.01% accuracy. Even they are going with very small data set size. It is not that much use as much our data set is. I will be showing you how much use data set I am using and what we are doing to get that much good accuracies. So these are confusion matrix parameters, and they done it with help of MATLAB. So now the third paper is this. Knee Osteoarthritis prediction using deep learning. This is a third paper. In this third paper, what dataset they are using, what models they are using, what accuracies they are getting, we will discuss them one by one. So almost 3 paper when we go through, for them they are getting good accuracy only for binary class, only 2 class. When it goes to multi-class, their models are failing. So this is our third paper. In third paper, they are going with their own custom CNN model as well as they are going with VG16. So these two models they are doing in combination, but what they are using as a dataset, they are taking Kaggle dataset with the 3836 images and which contains only 2 classes. Which contains only 2 classes, around 3836 total images with only binary classes, that is 2 classes, whereas normal contains 810 images, osteoarthritis contains 1540. They are using for training this much data, and 569 and 276 for testing, 210 431 for validation. And when it comes to pre-processing, so they are using like scaling, sharing, zooming, horizontal flipping. We call these techniques as augmentation techniques. In the pre-processing part, they are using augmentation, image augmentations. And when it comes to model building, as I mentioned earlier, this paper is using 2 models. One is custom CNN, their own model, as well as their own model with all these layers. And they are using VGG16, which is already pre-trained model on ImageNet dataset. They are using those 2 models. When they train, they are getting 93.45 on binary classes, 2 classes, not multi classes. For 2 classes, even 93 is very less, because the first paper was getting more than this for only 2 classes. Yes or no, like whether that is disease or non-disease like thing. Validation is 92% accuracy. When we are going with multi-class, we are getting 93 point something validation accuracy with our models. So now we discussed till now about what are the different papers, what they are using, the existing systems, okay, what their accuracies are. Okay, now what I will do is I will try to explain about this is little bit. Okay, then I will go to what proposed methodology we are using. So first of all, what is knee osteoarthritis? So knee osteoarthritis is a joint related disease where the cartilage bones and soft tissues will be there. They will be getting affected. Their size will reduce. The bones will start to come near to each other. They will try to collide, which will create a pain. Such a diseases. Okay. So now this leads to what are the cases? One is joint pain, stiffness, swelling, as well as reduced mobility of the person. He can't walk. In that case, will be created because of this. Because cartilages are like lubricants between 2 bones, you can feel like that. But when they get affected, the bones will come in contact each other directly. So it is like 2 gears without lubrication, how they will collide. So like that. How and why does KO happen? What are the reason and why it happens? So one most important reason is aging. With the age, normally above 50, the muscles there will be reducing because of so much of use. Obesity. What obesity will do is increase and accelerate cartilage wear. So previous any surgery happened or like that injury will be there. And what is genetic issue? If the problem is there in some people in your family, that may be shifted to the next. And repetitive stress. So like mainly it will come to people in athletics. So they will use it repeatedly, or who work in some hard work, like maybe I can say in any industries where the more weight should be carried or like that. In that case also it will be a problem. And again, the main cause is inflammation. Chronic inflammation contributes to cartilage breakdown. who gets affected because of this? Primarily the people with above 50 years will be getting affected because of this, and as well as women will be at high risk. And mainly when it comes to the repetitive stress based conditions, athletics, laborers. Okay, different stages of knee osteoarthritis is that grade 0, 1, 2, 3, 4, 5. Normal, doubtful, mild, moderate, and severe. And what are the available treatments are there for this? Is there any treatment available? Yes, like non-surgical treatments are like lifestyle changing, weight loss and exercise, pain management like corticosteroids, and physical therapy, bracing, viscosupplementation, hyaluronic and injections. And when it comes to surgical treatments like arthroscopy, osteotomy, and partial total knee replacement, entire knee replacement can be done. These are three different type of surgical treatments. So now, what is the number globally? A number of people getting affected because of this. Over 650 million people are affected globally, according to WHO, World Health Organization. And most common cause of disability in adults over 50. Okay. Almost all adults who cross above 50 are are having this problem. In India, affect more than 15 crore, that is 150 million people. 1 in 5 Indians over 50 show sign of this KOA, that is knee arthritis, increasing due to sudden lifestyle obesity and aging in India. And why we are discussing all this is the amount of the treatment you see. So country like India, in our country, the total knee replacement cost is around 1.5 lakh to 3 lakh. It depends again. So when it comes to USA, it is increasing to very high number, $30,000 to $50,000. This particular TKR treatment we are discussing. If you take even non surgical treatment also, 2,000 to 15,000 per month in India, treatment for this. So now in this case, how deep learning will help? So as you see the above classes, there are 5 different stages. So 5th stage is causing so much of issue there. So what if we can able to properly detect and analyze the proper stages at the initial stage of the disease? We can treat it with less amount. The cost that is taken for treatment will be very less. Okay, so that is the main aim of the project. We want to make sure that the disease is detected before the final stage, so the treatment can be done easily and with less money and with less pain for the patient. And the treatment success will be 100% if you try to treat it at the stage 0, 1, yeah, 2, but 3 and 4 it is bit hard. And here deep learning advantages are they only. Okay, we are using deep learning. Okay, what are the structural minute structural changes also it can understand, and objective fast and high accuracy, because human is having a limited calculation stuff. For example, if there are 100 type of dogs, we can remember only 10 or 20, but deep learnings can try to detect more than lakhs also. It doesn't matter, number doesn't matter if you train them properly. So they handle more data, they can handle more data at the same time. So because of this, we are going to build the deep learning based project. So why I am telling you all this proper theory is that if you are building some project, you need to know why we are building it. Okay, if we are building, what is its importance? So now what we will do is, I will try to tell you now how we build the project. For example, we have built 3 different models: EfficientNet, Dense 101, as well as ResNet 50. Even with us, we can build hybrid models with combination of 2 to 3 models. We can have 2 to 3 models in hybrid, and we can build the hybrid models also, which can give the better result. In our case, first we are taking our dataset, and then we are balancing our dataset, which only third paper is discussing about. So in our case, you see, Each class we made the 2000 images for each class. 2 into 5 around 10,000 images, so which is lot larger than the any paper that we discussed till now. So why we are doing this, why we are making sure our data set is well balanced, I'll tell you here. For example, if there is a box like this, okay, which is having two sections, so here there are 1000 apples, okay, so 1000 apples, and here are the 10 tomatoes, okay. Here there is a small boy here. Now you want to train him with the 100 apples and 1 tomatoes one by one. So after 10 apple 10 tomato will be not available. So 100 apples you will 1000 apples you will train one by one. Finally after training him 20 times, let us take 1 or 2 times, not 20 times you are training. So if you ask him, he will be learning more much better about apple rather than the tomato. This is because of the imbalanced distribution of the data. So imbalanced distribution will make our model overfit or underfit. It will learn much better about the apple but less about the tomato. We call this a overfit issue. So now to overcome this problem, we use augmentation technique. What augmentation will do is, for example, initial 10 tomato will show them as it is, but 11th tomato will take one from the same box, but now we don't show it as it is. We'll take that, we'll tilt it little bit, we'll take away, zoom it, we'll rotate it, I'll show it again. Same tomato, but the orientation and the physical transformation of that image will make sure it looks little different than the existing. Okay, so that's what augmentation, creating the new data by inducing the variation within it. We are using that augmentation, we are using set of particular methodologies. And then after the augmentation, what we are trying to do, once our data set is balanced, balancing the data set will increase your accuracies minimum 20 to 30%. If you are getting very less amount of accuracy, the training of validation, or if your model is already overfitting, whether training is having very high accuracy, validation is having very less accuracy, because of the imbalance in data set, it will be normally. And once we do that, we are not leaving as it is, we are implementing our own pre-processing techniques. So for example, Gaussian noise removal filters and image enhancement filters. We use particular named filters here, and then we are going to do edge detection filters, where we detect the edges of that area, bones are like this, and then we are going to make our data set highlighted these edges without any background intervention, because we are going to make sure the background any noises are suppressed. So once I do apply all these pre-processing techniques on my images looks like this. You can see the region, the bones, their structure is being highlighted. We are not touching the background. Even you can see here there is a blur white thing, but we are not taking it into consideration. We done such a pre-processing, such a edge detection technique where we are not taking this blur thing. So we are making sure this blur doesn't matter. So we done the pre-processing in such a manner, background is suppressed. Background should not affect our result. So only the bone parameters, the bone structure are taken into consideration. So this is a way of highlighting the region of interest using multiple pre-processing techniques. So then only we are splitting our data sets. Then we are building our models like EfficientNet Bina time taking, DenseNet 1-to-1, ResNet 50. 3 different models I am taking. For every model I am training it for 20 to 30 epochs. I am getting 97.75. The same dataset that is being used by the paper 1 for multi-class, and 2 other papers are not using multi-class because they are going with only 2 binary classes, only 2 diseases, that is healthy or any issue, healthy or knee arthritis they are doing, but only first paper used multi-class, but they were getting less than 67-57% accuracy. So then they worked on only binary classes in that paper. So in our case, validation is 92.90, training is 97.75, which is the best accuracy. And then we save the model here. You can see the graphs. And then this is our complete classification report of our model, where 93.80, nearly 94%, F1 score, precision, recall, and you can see all of them here. We are getting at most the best results for all the classes. And then we apply explainable AI, as I mentioned. That paper, first paper even tried to discuss about this. In our case, you see the bluish color. This explainable AI is such a technique where it will try to highlight the region of impact, the region which impacted a lot for the classification. It doesn't mean the remaining area is waste. It means that the particular area is most impactful than the remaining area for the classification. This is a way of analysis. Once we do this analysis, we're gonna build codes like this. We're gonna build index HTML codes for front end. We're gonna build this web application, whatever you saw initially. So we built with help of Flask in the app.py. Okay, you can see we create like this databases for all the different stages. Then we create our template files like index file, HTML file, result HTML pages, and then we create a static CSS elements and images as a background. And the most important thing is that our app.py will be communicating with our digital knee cancer.h5, which we save there. The deep learning model which we save in our Jupyter notebook will be loaded here. So that will be used for the detection in the real time, as well as the cause, the recommendation, treatment recommendation, as well as the feature what it may cause, in future what it will lead to. That also will be guided by this model itself. Digital knee x-ray, digital knee underscore model.h5. So this will give us all those informations. So you can see all those codes here. So this is completely built with help of HTML, CSS, JavaScript, and Flask. So now we'll see the demo for few images. So this is our home page where we are trying to mention what is this knee osteoarthritis detection using deep learning. So as I already discussed those information in our document, just like that I am trying to print something here, and what are this cause and what is the risk factor, what are the different stages, and what are those stages 0, 1, 2, 3, 4, like 5 total stages are there. And treatment options, what are the different treatment options are there, that also being displayed. If you want to display more information here, we can help you with displaying those information. If you want to display any images, we can display. Why only deep learning? So whenever data are images, it's better to go with deep learning instead of machine learning, because the deep learning can handle high dimensional data than machine learning, because the image is 3-dimensional data. You can click here, you can choose a file, whatever the scan images you have. Let me take the severe images and I am going to upload here. So now you see here, within a fraction of seconds you are going to get a result, the accurate results. So this is a 4th class, there is a 5th class, the condition is severe, and the cause is like this: severe loss of joint spaces, large bone deformities, major cartilage loss, advanced osteoarthritis features. So what is the treatment for that? Treatment recommendation: surgical intervention of often recommended for this actually, and total knee replacement is much recommended for the last stage, along with strong pain management and physical rehabilitation. Whereas if you take the mild joint space narrowing is there, possible small bone first, they call it osteophytes, and early sign of cartilage wear. Next stage is that. So treatment: physical therapy can be done, pain management, weight control, and possible use of joint supplements to solve the problem of this condition, that is mild stage. And when it comes to the moderate, so for moderate joint space reduction, more prominent bone spurs, and clear sign of cartilage degeneration in the knee. And what is the treatment for this? Treatment is medication for pain, inflammations, physical therapy, possible knee injections like hyaluronic acid or corticosteroids. These are the treatment recommendations given for this knee osteoarthritis condition, that is moderate condition. So now I think you understood the entire process, how we did the analysis, how we defined our methodology, how we are getting some good result, and how finally we have built a complete working web application. If you want the entire working code and if you want us to support you in building it, if you want support from us building it from base also, we can do it, and we can provide you the documentation support, classes for explanation and mentorship. Everything will be provided to you. You just need to contact our team to the given number below. You can just WhatsApp or you can just call us. So we will be responding and we will be helping you to solve the issue. So if you have any question, you can just contact to us and you can ask a question. If you want the live demo also, you can contact us. We can show you a live demo also. And this is all about today's session, and I think you understood this process. If you want to know anything about this project, yeah, some other project also, you can call us. Otherwise, we already have so many videos in our channel. You can go and you can watch them. You can share these links to your friends and colleagues who are in need. Thank you very much. Don't forget to subscribe and like our channel. Bye. We'll see you in next session with some good project.